All right, so now that we've talked about object-oriented programming, let's take this example. We've worked on it for a couple days and turn some of that into object-oriented. Not the full thing, so I guess the player and the coin is what I had in mind. So what I did preparing for the lecture. So I got my example pulled up over here. So I'm gonna go ahead and share my screen. I guess one thing to note is I mentioned everything in Python is an object. We don't have any primitive data. That will become an issue soon. Those who are also in the SDEV 140 class, we're going to talk about this on Wednesday. Because like if we need to talk to another machine, that becomes a problem because the other machine might not be using Python. And a Python string is not compatible with the standard string. Right? When we say string of characters, we probably think Unicode, right? Just a bunch of Unicode data. But that a Python string isn't exactly compatible with that. So like if we're going to have machines talk to each other, we have no guarantee Python's on the other machine. So we have to cast our strings into pure Unicode, turn our strings into pure Unicode data in order to talk to the other machine, because like, we don't even have raw data. We don't even have primitive data, the basic integers. Like here where it says frame equals 0, that's an integer object. Everything in Python is an object. And that's what's going on here with the import stuff. So in Python, it takes it to an extreme. We don't even have to do the class stuff in Python. We could write a script that has a bunch of variables. I'll use this one that has a bunch of variables built in and methods. So it has behaviors like initialize. It has objects built in like a clock. Methods like set, repeat. That could just be put in a regular module with just variables and methods and avoid all the class notation, unless we want to nest classes inside of it to create nested objects, but that's getting a little ahead. And then variables could hold variables like quit. This variable just holds, that's just PyGame.quit is just a variable in a regular looking Python script, no class notation, that stores, well, I guess at introduction level, it's not quite going to look regular, but it stores the XY coordinates of the close button, so that when we have a mouse click at the same XY coordinates on the screen as the close button, it matches what's stored in this variable. There's a variable called key down. Well, sort of layered variables. So one of the variables is k_w. So that when we press the W key, it can check and see if it's equal to what's stored in that variable, which is stored in this. I'll say layered variables for now. It's not really part of the class here. That was just a little side note. So we can just write a regular code with a bunch of variables, some functions in there, and then we use the import line, say whatever we called that Python script, import it, and then call those methods and variables from here. Those are static or semi-static. That's a common word in computer stuff you probably haven't encountered yet. Static means there's only one copy. So having said that, I'm going to jump to the class notation yet. That is Python specific. So another nice thing about the class notation, we have both methods in Python. We can just use a regular old Python script or the class notation. And in the rest of our languages, it is the class, the blueprint or the design. So if we use classes, that matches the rest of our programming languages, but it's not the only way we can do object-oriented in Python. I guess is the point. But we're going to do class stuff for the example here. So I'm going to close this and work on a copy of it. That way I can send this out after class at the state it's in now. So copy that, paste that, and rename that as class example objects. And then I'll rename the script the same thing. Rename this as in class example objects. That way I can send both of them out separately for your reference later as you mess around with this stuff, because it's an active subject. We got to practice it to kind of learn what we're doing. Oh, then I need to open that one I just renamed. Edit with Notepad++. So while it fits that technicality that Python only has objects, we don't have any primitive data. So technically it is object-oriented programming. It's not really those concepts that I just talked about on the board. So we want to change that over to that. Typically, it's considered good form to put your objects somewhere else. And one general way is every object gets its own file. So each one of our objects has its own file, and then we'll import those as needed. Python, we kind of slip away from that and tend to build libraries where we'll have a whole bunch of objects together because of that thing I just mentioned, because then we can mix our classes and our regular old variables and functions outside of classes, and we can mix and match them. But I'm going to kind of follow suit there. And we build in Python, we usually build libraries instead of giving each class its own file. So I'll create a new file for that. Well, it's going to have some PyGame stuff, so I'm going to import PyGame right away and save it so we get the color changing. Class example objects. This will be, I'll call it game objects.py. So it is just a Python script still, but we have a couple other things we want to do with it. Let's see, I'll skip that. I was going to include the auto-generated documentation in the comments, but that's not necessary for our subject here. I just wanted to show you that those websites of documentation, when we have to look stuff up about programming, we don't write those websites. We just put special characters in our code and run it through software that will generate those websites from us based off what we put in the comments. But there might be time for that later. I was going to do that if the thing ran, if we had extra time, but I don't think, it's already been a while, so I'm going to skip that. So for our class notation, you may have guessed the keyword is class. And say we have a class, we have a design for something, we have a blueprint for, I'm going to call it game piece, just the general stuff. And then we need the syntax, we need parentheses and a colon, and then that general Python syntax that's been mentioned before. We have a keyword, what's specific or unique to our situation, followed by a colon, and then everything inside of it gets indented. And everything inherits from the object. That is implicit, it's implied. We don't have to say inherit from object. That automatically happens for everything in Python. If we want to inherit from another object, which we will have something inherit from this object in a moment, that goes in the parentheses. And the first thing we want to do is define our constructor, or the initialize method. And initialize abbreviates nicely to something that makes sense for a constructor, because it's we want to define what's in it. So underscore underscore init underscore underscore, then parentheses, a colon, and we'll indent to define everything that's going to be in this object. And with the class notation in Python, the very first parameter every time has to be self, or something. It doesn't matter what we call it. It's a reference name. We can make it up ourselves. But the very first parameter is when we say coin is a new game piece. Every time one of these methods gets called, the first thing to get passed in as an argument is the coin we created in that example. So it does pass in the actual instance of this class. So that has to be first. It's fairly standard to call it self, because that word just kind of makes sense. But it is a reference name. It's just like variables. We make that one up. It's not like init. Somebody else made that one up. Self is fairly standard. That's what you'll probably see in reference materials. You might as well stick with that. But that has to be the first parameter every time. And then the other stuff that we need. So I'm going to look over this object here. So over here, that stuff I pointed out a moment ago. I have an X, a Y, and a speed. And this stuff is pretty unique to the player, what's being controlled. Oh, an image. So X, Y, a speed, and an image. And I think everything in our game is going to have that, right? We're going to have that X, Y position, the coordinates on the screen, a speed, even if that speed is 0. That way we can generalize it. Instead of saying some things don't have a speed, we'll say some things have a speed of 0, which means they don't move. That way we can generalize that to everything, and an image. And this one has a single image. This one we needed a list. So when we go to generalize that, I'm thinking the generalization on it would probably be a list, because we can put one thing in a list, but we can't put a list in one thing. Does that make, if that made sense? I think I said those words correctly. We can have a list with only one element, or with no elements if we don't have an image, a control object, which we haven't seen yet, but we will soon. Some things won't have an image, but we probably want to have an image, and then we'll just, when we have the imageless things, we'll do the same thing like speed. A speed of 0 means not moving. We'll have a null image instead of creating a separate object that doesn't need them. That way we can generalize it to everything. But we know we'll have a speed. So I'm going to pass these things, set these up, and I'm going to make a change here. So we'll have the coordinates, X and Y, then we'll have a speed, then we'll have an image, and that's what everything in our game is going to have. So then every other object we need in our game, we know it'll have this, so it can inherit all the stuff we put here and then add to it for what it needs in particular. So like this, everything's going to be passed in as needed. We can also put default values here. And for video game stuff, I really like to include default values, because we can say X is 0 and Y is 0. Speed is 0 by default, and image is an empty list by default. So not really anything there, there's just a default. So that if we don't pass in a speed, we're not going to get a crash because there's not a speed for some method that gets called. Or if we don't pass in a Y coordinate, we're not going to have the program crash because there's not one, because there's a default. It's just, we're probably going to override that default whenever we instantiate an object. So we'll take those things in, but then we need to put them in someplace more secure, more specific. More precisely, the word that we used here, and that's the last time I'm going to say that's open, the self. We need whatever, that's our particular instance of the object. That's the one we created from this blueprint, is the first parameter. So we need to take all these values we pass in and specifically put them in that self object. So we can set them up, and there's something you'll probably see in reference material. It's quite often done because in most of our programming languages, when we do object-oriented stuff, we can say things are private. They cannot be accessed from outside of our class. It's sort of a layer of protection, like that donut picture I drew, where there's that inner circle that protects our data. It can't be accessed from outside. So that's very common, but we don't have private in Python. We have this semi-static thing, which doesn't make it any harder to access. It takes whatever our class name is. We just say the class name dot underscore underscore, and then we can still access it directly. So we still have access to it. So there's no private in there, but a lot of people go ahead and use the double underscore on the variables to treat it like private. So, and then that's fairly standard, so that when other programmers see your code and see that double underscore, they're like, oh yeah, this is Python. We don't have private variables, so this needs treated as private. But to make our example easier, I'm just going to bypass the private because we have access anyway. And this object we created, which when we actually go to use it, is going to be called something other than self. Self is our internal word for it to the design. We'll probably have one called coin and one called player that we're going to use. It's going to have something called .x, a data field called x that we can access by just putting .x next to whatever we actually call it in our code. And that's going to equal the x we pass in. So most of our init method, the initialization looks like this. Whatever gets passed in, we just go ahead and tack it on this, do a self dot, that variable equals the one that was passed in. Notice those are not the same thing. This one, which is this one, is x, and it is just x. Whereas this one is self.x. The dot does not separate things. It connects them. It's like a padlock. And they go that way. It's not like a period in a sentence that separates things. The dot operator is like a padlock. It puts them together, and they cannot be separated at that point. So not quite the same thing. So we need to actually load in those to our object instead of just as parameters in a method. The image is a little bit different because we might not have an image. We haven't seen any control objects yet, but hopefully just from the name, you probably automatically have an idea of what the control objects do, right? The background things that handle stuff like words on the screen and general control of the game. They don't need an image. They're in the background. So we might have an image not get passed in at all. So I'm going to check if the length of that image, not self.image, if the length of that is equal to 0, that means there was nothing passed in for it. Then I'm going to explicitly set self.sprite. Actually, I'm going to change this. This is a list. So I'm going to put images. I'm going to make that plural. I think I meant to do that because we might have more than one image. We might have one. We might have none. But however many images we have, we're going to use that as the sprite. Did I mention the video? Sorry for the sidestep here. When we loaded these in, we just did a copy and paste. There's a way to do that in one line. So I just did that as a video. It's on Ivy Learn in the page called Video Lectures. The way to do that in one line instead of 20 lines. But it's it might be a little complicated for people brand new to programming. And the pieces kind of seem, it's a high level programming thing. So I did it as a separate video and did the easy copy and paste logic for class. I think I forgot to mention that, sorry. Did I mention that earlier? Anybody remember? It's a long class. Right. Okay, so sorry, back to where we were. But there might not be an image at all. So if there's not an image, then we want something we can explicitly check very easily to see if there is none. So really, we want a null value. We want that empty. We want that less than 0. we want that so empty there's not even a less than 0. Most languages that's called null. In Python we call it none. And then we can just check if the sprite is none. Otherwise, we can just set we can kind of loop through however many we have. Because if it's not 0, then there's 1 or more. We're not going to have a negative number of images passed in. The smallest is 0. So we can start. Sorry, having trouble talking. We can start by setting that sprite thing to just be an empty list, and then we can loop through that images list we passed in. So for each pick in images, we will do self.sprite.append pick. That's the keyword, the built-in method to add another element to a list. So we start with a list that doesn't have anything in it, and then we'll just start appending stuff on as we loop through this big list of images that were passed in, or small list of images that were passed in. So if it's 0, we want to make that more explicit and make it less than 0 and make it empty. But if it is 0, or if it's not 0, then there's at least 1. So we'll make a list of sprite images that has at least one thing. And one more thing to do here is if we do have images, so that takes care of our XY speed, state, and the left. Those are unique to our player. That loop will load in lots of images for the player, or a single image for the coin, whatever that was, single image for the coin, take care of that. But then we'll want the bounds as well. And the same way we pulled them from the player here, we can just set them here. Do the same thing here. So after we load those in, for our quick example, I'm going to go ahead and assume all the animation images are the same. That's not always the case. It might, in some situations, this will be a little more complicated, but for us here, I'm going to go ahead and assume that those are the same. I'm also going to add a bunch of white space here because I don't like working at the bottom of a screen. So I'm just going to hit enter and get some white space there first. So after we have those images, I'm just going to look at index 0 because we know there's going to be at least one thing there and use that for the bounds. So self.bounds, that edge, the thing we use to detect collisions, see if we bumped into another game object, or game piece is what I call it here. The bounds is going to be that self.sprite. Again, the dot is not a period like English that separates things. The dot is the dot operator in programming locks things together. So we do have to refer to the self if we want that list of sprites. The self.sprite index 0. Then did I do that backwards? Oh no, then get rect. For a second, I was thinking I need to type the PyGame word there, and the PyGame's a library, it always goes first. So same thing we saw earlier, we'll just get that, and we could update the bounds here, but that's something we're going to want to do a lot, right? We're going to need to update those bounds in places other than just our when we initialize our object. So I'm going to come down a couple lines, and that'll be the first method we put in here. We'll define a method, that's our keyword in Python. Define some sort of function, something to do. I'll call it update bounds, because remember the bounds, the boundary around our image is separate from that image. So they have to be handled separately, which by itself doesn't need anything. right? If we say update bounds, that's this referring to this object. We don't have to pass anything in. But remember, the actual instance of this class, the object itself, will always be passed in. So we do have to pass in that self one. So in a class, when we say self, that really means nothing's being passed in, because we don't type that. Python does that in the background. And if when you're thinking and planning, you like to write out all the methods that you want to use and then come back and check them later, there's this keyword pass that just means don't do anything that you can use to avoid a typo. Because if we did that and then like, okay, the next method is method, this would throw an error if we tried to check it, because after the keyword define, our unique situation, a colon, we have to have something indented. So that's what the word pass is for. If you want to go ahead and set up all your methods. So thought I'd show that. But in this case, I already know what to do there. Basically the same thing we already saw, the logic. So really what we're doing is we're reorganizing this. We're just organizing this nicer. Same logic we already saw. Nothing's going to change logically. So our bounds happen to have an X and a Y coordinate, and we'll just set those to our player's X and Y, which here in our object are called self.x or self.y, because it would apply to other objects as well. So like self.bounds .x, because that's the thing we're creating, has a data field called bounds, which has multiple things in it, and one of those being an X coordinate. So we'll set that to self.x. And just remember that self dot everywhere. And then self.bounds.y is the self.y. And then another nice thing, one thing that a lot of people really like about the class, doing it with classes instead of normal modules or procedural code, is that our order doesn't matter much. The classes will be compiled, not interpreted, so we don't have to worry about order like we normally do in Python. So even though, so I'm going to come up here and call that method that's not written until down here, which is part of the self. So I need to do self.updateBounds. So the classes are compiled, which is why we want to do those separate from where we're going to use them. Because then we have a compiled file. Because if we do them in the same place we're going to use them, we have to worry about order like always. And oftentimes we need to do things like this and ask for a method that we hadn't written yet. That's because our constructor does have to go first. So usually at the introduction level, it looks like a little bit extra work. It does pay off. It really will pay off. Does that make sense? Can I get some confirmations on that? Some yeses, nos. Is there a head nod gesture? I know they added a whole bunch of emojis on the last update of Zoom.
Yeah, that makes sense. I also just realized my mic wasn't fully plugged in.
Oh, okay. Yeah, your thing lit up for a second, and I thought it was, I could see the mute icon, so I thought you just hadn't clicked that yet. But that makes a difference.
Yep.
Yeah, so it's, so in our class is the thinking like a programmer thing. But once we get these blueprints together, then we have capsules to work with. Everything's encapsulated. Then we have this big bucket full of what it means to be a game piece, and we can use it all at once. So it's an organization thing more than anything else. So I'm going to go ahead and do another one to show the notation for inheritance, because that would cover our coin and a whole bunch of stuff about our player, right? The coin, we got the X and Y, the speed's going to be 0, the image, there's only one image for it, the bounds for it. So that covers the stuff about the coin. The player has a couple more things in it. So let's look at the inherit. So the player has all of this. So we want to inherit all of this. So the player will be a child of the game piece. So I'll come down a couple lines. And once again, start with that keyword class. And I'm just going to call it player here because nothing else is springing to mind. The parentheses, a colon. And in those parentheses, we say what it inherits from. In this case, we want to inherit from game piece. And a really good form is copy and paste as much as possible. Since I scrolled up, I'll go ahead and do that. To avoid a typo, or maybe I made a typo the first time. Right? The computer doesn't care how the word game piece is spelled. If there's a typo in it, as long as that typo is in all of them, it's no problem whatsoever. And now so it's going to get everything we just defined, and we're going to add more stuff. So kind of like the parent-child relationship in real life. Parents, hopefully in an ideal world, which obviously I think everybody's aware we're a long way from an ideal world. We live in, our world isn't even close to ideal, but in an ideal world, parents would work to have a good career, accumulate some stuff, and eventually their child's going to inherit that stuff, and then they're going to have a working career, good working career, and add to that. And then their child inherits a couple generations worth of things, and throughout their working career, they add to it. So just like that, we're going to take all of that stuff that it means to be a game piece and add a little bit to it. So once again, we start with our init method, which is initialize, but it's init kind of makes sense for what we're doing with it for a constructor. It's what's in it, in the object. So we always have to start with self. And I haven't run a test in a minute. I've typed a bunch of code here, right? I've typed a bunch of code without a test. So I'm going to come over here and it doesn't do anything. But if there's a typo, it'll throw an error. So if I'm going to go ahead and run that, first off, I have to navigate up a level. So even in your strings, if you haven't seen it before, ... means go up a level in folders. So change directory up a level, look at what's here, then change directory into class example objects. Oh. So what's on the directory. And now it doesn't do anything yet, but if there's a problem, it will throw an error. So if it doesn't do anything, I know everything's okay. Otherwise, we can address the errors. Might want to remember to check that. And that's why I went ahead and used the password here. That way it doesn't throw an error from that. So Python run the game objects.py script. Yep, no errors. It just gave that hello from PyGame message. So it's always good to check that. So what does our player need different? If we come back over here, and this one we just put together has now become our rough draft of a design. So we got X and Y coordinates and a speed. We'll inherit those. Oh, looks like we need a state and left, which when I put that in there, I think I'll go ahead and call it face left to be a little more explicit. The image will inherit that. The bounds will inherit that. Oh, so it looks like we just need the state and the face left. So over here in our init, the first parameter is the self, the thing we're creating. Then we're going to need a state, the game state of our player object, and which way is it facing. So I'm going to put face left. And again, I like to go ahead and put in default values. So with things like the game state, I like to go with words. I think that makes debugging a lot easier. You could just as well say state 0, and then state 1 is walking. but I find that confusing. I like words myself, but obviously the point being there's more than one way to do it. And I'm going to start this with false. It doesn't necessarily matter which way. And now I'll move that over where it's not behind the thumbnails. Now we need a way to pass all of this up to the parent object. We also need those passed into our constructor, which we're going to pass right back up. And there's a general one in Python. Actually, there's two general ones in Python. The first one, and you'll see it in reference material, is asterisk args. And the second one is 2 asterisks and quarks. So args and quarks. So the reference names, we can call them something different. This is kind of the standard. When the guy developed Python, these are the ones he used. So that's what we typically use in Python. Just convention, that way when somebody else looks at your code, they know what you're thinking about or know what you're talking about. Arguments are, remember, parameters are received and arguments get passed in. So that's just, it's expecting some more arguments to be passed in. And in the case of the 1 asterisk, that's single value arguments, so variables. Quarks are keyword arguments. So that's our lists and our dictionaries and tuples and the things with multiple values all at once. And in this case, we need both. We'll need both of them. We pretty much always use both anyway, because if they're empty, it won't hurt anything. The people who put the Python programming language together are really good at what they do. Because we have the X, the Y, and the speed, those are all single value data points. So those are args. And images is a list. So that's the quarks. So we need both of them in our case, but we usually do both of them. So when we initialize a player object, we're expecting to receive the state of the player object, a true or false, to saying whether it's facing left or right. And I usually put left in the name for that, just because right could be misinterpreted, but still just kind of made up names. And then other stuff. So it's like, okay, here's the new ones. Here's the other stuff that goes to the parent. So that stuff that goes to the parent, we have to pass up to the parent. So the first thing we want to do is this method super with parentheses dot underscore underscore init underscore underscore. And then we pass stuff up to the parent. I have to put self here. I don't think I do. I don't think I need self, so I'm just going to pass up those args and quarks. So all the other stuff gets passed to the parent. If it throws a message, we might have to come back and put self there, but we're not passing our self up. We're just passing the stuff the parent needs to know about, and the parent has its own self up here. And it always looks like that. So call the superclass. So this is another keyword. I mentioned private. Along with private, which means it's only accessible from inside of that class, there's also protected, which means the children of that parent class can also access it. So that means that's what's going on here. This is a child of game piece, which means this parent can access its child's stuff, right? Kind of like real life, right? A parent's own children are allowed in their house. Everybody else has to knock on the door and ask permission to come in. That sort of thing. So that's the keyword. The technical term for that across different programming languages is going to be protected. So the init method is protected, so we can access the parent class's thing in order to pass up args and quarks, which almost always looks exactly like that, because that's just, oh, those do have to go last. Args and quarks go last on the list, and then it's just like other stuff, and then that other stuff gets passed up to the parents. And then we need to do the same thing we did before with that new data. and assign it from just a simple variable into an object variable, an object data field. So we'll call self dot state equals the state that was passed in, and self dot face left equals the face left that was passed in. And then when I was preparing the example, I just put two methods in here to kind of fill this up. Obviously, there's wiggle room, more than one way to do this. This is what I've come up with when I was preparing the example. Is what's the main thing our player does different than every other game piece? It moves, right? So it's going to move. And I'm just going to kind of set up the method headers. A lot of people like to do this. Think about all the stuff that needs to happen and then like start at the broad level and then come in and narrow it down to the details. And it also needs to change which way it's facing. So I'm going to make methods for that. Go ahead and set up the method headers, and every method in the object, the very first parameter needs to be the self itself, or however you want to try to phrase that thought in English. The reference to the thing we are creating has to be the first thing. Then for our move method, well, we just need to know which direction to move. I can spell it right. D-I-R-E-C-T. So self, and then which direction do we want the self to move in? And same thing for facing, only I'm going to abbreviate it. This is kind of the way I write code. So in the second one, direction is a Boolean. True means we're facing right, and false means we're facing left. So for the Boolean ones, I abbreviate them. And for the actual directions, I set up the spell out the word. That's just my own personal style of keeping those straight. Being consistent when you write code is another very useful thing for when debugging. And then we'll call that self.face left, which we inherited from the parent, right? Oh wait, no, the face left we didn't inherit. The other stuff, we'll get to the inherited stuff in a second. And we'll be passing in a true or false value. So I'll set a default of false. That way, if we just say set facing and empty parentheses, it's going to try to make your character face right. But I'm going to plan on passing something there anyway. And for the direction, well, kind of like we saw over here, our logic that we've already seen work is we adjust the y value by the speed, or we adjust the x value by the speed. And we also need to change the player state to walking in order to handle that animation. So if we're moving, player state needs to be walk. Can I do this here? I'm going to leave that off. That might clutter up the example. So sorry, we can do that separate as well. We can access that player state from outside. So I'll just leave that like it was. And here I'll just handle the moving. Because we just need to know which direction we're going. So if direction equals up, and again, I like the strings to keep these straight. Because if we're going up, then our y value is changing. And in PyGame, up is like the lines on a page. So to go up means we're going to go down by self.speed. And here in our constructor, we don't have y or speed. Those are in the Args and Quarks, the other stuff that we passed up to the parent. If it's not up, is direction, well, I guess we could do if it's not up, then is direction equal to left? Oh, I'll do down first. Up, down, left, right. Actually, I'll write all this. If it's not up or down, whoops, made a typo. Nobody pointed that out. That should be equal to, right? If the direction that gets passed in is the string up, then we'll adjust our y value. Or down, or left, or right. And instead of doing the else at the end, I like to go ahead and do else if all the way through, the elifs all the way through, or else if in other languages. That way it is explicitly checking the condition. We don't accidentally ever go right because we forgot to pass something in. So if we're going down, our y value is going to adjust in the positive. We're going to reassign it by whatever our speed value is. Same thing for left, only for the x. So this object we're designing has an x value, an x data field. And if we go left, that means we're going to subtract by the speed data we have about this object. Self.x. If we go right, then we're going to increment by our speed data. Do those things make sense? Logically. Like, could you play around with that and figure out some other things that you might want to do in your games? Because that's the goal, right? This trivial class example probably isn't your goal with the video game development course. That's just something that fits in our time constraints, because we are under very tight time constraints in the classroom. Does anybody have any questions about putting the objects together? So it's like, that's the generalizations. Okay, I assume the silence means no questions. So now let's go instantiate these objects and actually use. We have a design, so let's go implement that design. So we'll come over here and I'll start with the player image. So I'm going to select all of this stuff, and in the editor I'm in, Control-Shift-Q comments those out. The comment a big block at once is different in every editor. So if you check your edit menu, it should have, and find comment, uncomment, you should see the keyboard shortcut for commenting out large chunks of code at once. And well, I'm going to need this list, so I'm going to come after it because, well, this is back to the script we're actually going to run, so this time order does matter. So I'll come after this. Oh, our bounds are included, so once again I'll highlight that. And where I'm at, it's Control-Shift-Q, but again, check your edit menu and you should see the keyboard shortcut for it. So once we have it, we'll just do, we'll create an instance of that object. So our player is going to be a player object. And then we'll pass in all this stuff. But first, does Python know about our player object yet? Anybody have thoughts? I can point you towards a hint. We had to do this because even though the PyGame library was written, we didn't know about it until we wrote that line. So we will need to do that. It's not in, we're in the same folder, so we don't have to do anything special. So real quick, I'll put yeah, I'll go ahead and use the I usually do the from notation. Well, I will go ahead and do that because I want to express a point. Also, to import stuff, we can say from the library we want to look at. So from game objects, that library we just made, import some stuff. And we can put out a list, or we could throw in an asterisk, like the wildcard selector. And well, we're getting ready to move on from Python, so I wanted to make sure and point this out. Some of y'all may notice that looks like a SQL query, right? From this thing, import some stuff. It is not a coincidence that that looks like a SQL query. There's a lot of reasons for it, but that's for further down the road. So I just wanted to point that out. It's not coincidence that it looks like a SQL library. So this is an alternative way to import stuff. When we just said import PyGame, we had to type PyGame everywhere. If we use this notation, we don't have to say what library it came from. We can just start typing the names of the stuff in that library. So that's what I'm going to do. If you just said import game objects, you come down here and type game objects.player in order to go to the library and get the class out of the library. But we just, with that other notation, we can just say, just start using our stuff. And then what does our player need? So, well, it needs an X value. So we'll say X equals, where were we? 234, and a speed of 3. So we'll pass in an X of 234. If you do it in order, you don't have to say what it is. But in order is kind of funny here, right? Because that's spread across a couple objects, and we use the Args and Quarks. So some of that stuff we're passing in, we basically just said and more stuff. So order is kind of funny. So it can be a little bit better to actually say what value we're filling each time. Y equals 234. That way we don't have to worry about which one, about the order so much. Speed is 3. Images is going to be something we'll get here in a second. What else was there? Face left and state and face left. State, start in idle, and face left equals, so I just repassed in the default values. It doesn't hurt to do that. Now images is a little bit different, because here we loaded all these files in, and over here our object handles all that loading. So all we actually have to pass in here is the file names. So we don't need all of this stuff, which I'm just going to delete all of them except the first one. Instead of trying to edit that down in one spot, I'm going to edit just the first one back to a line and do that copy and paste thing we saw earlier. I'll select that, copy 2, 3, 4, 5, 6, 7. And then we can change these. So like 20, 19, 19, 18, 17, 16. And that is just something that from experience, there was a lot of lines that needed small changes in each one. But to redo the copy and paste means an even smaller change. instead of the change spread out in different places. So over the years, I've found that sometimes it is better just to delete it and retype it, especially if it, because from experience, I think I know that what I just did there of deleting that and recopy and pasting it and adjusting those numbers is quicker than trying to adjust every single one of those lines one at a time. And then that is a list of file names that we can pass into our object. Images is that player sprite list. Now we have a little bit of updating to do. One way that can be nice and quick to check for updating is if we come over here and run that, it's going to crash, right? Because we no longer have a player capital X variable. We have a player object, so we have a player .x data field. So one quick way to find those changes is to just run the game and see what line it crashes on. What did I call it? In class example objects.py. Run it, wait for it to crash, and then I can see the next one is on line 57. We also have Control F or Control H. Some do Control H. Some look for everything that had player capital X, and I'm going to replace that with the player object has a .x in it. So we could scroll through, replace them one at a time, or just replace them all. Okay, those have been changed. So now we can go to player capital Y and change that to player object .y data about that object. Oh, whoops, not fine. Next, replace all. What else do we have? Player speed is one word, and camel case can now be the player object contains its own speed data. Replace all those. It's called player left. Player object has face left data. Replace all those. What else do we need? Is that all our data fields? Oh, state. We also had player state as just a regular data field, but now our player object has its own state data. It's more organized. Everything about the player is included. Replaced all 8 occurrences. So now all of that should be updated so that we have the right variables in places. Here it is. Back up. Oh, missed a couple. Let's see. Line 57. Oh. A typo in the game object I didn't notice earlier. Here is what was already erased. It was already erased from the list. All that stuff from changing the list. Because at that point, we don't want the file name. We want all this, right? The pygame.image.load, which we're getting short on time, so I'm going to copy that. So I'm going to copy it from there. And when we make our sprite list, that's a list of pygame.image.load, each picture in that list. Sorry, I must have been talking when I was typing that or something. Oh, still a few errors. Oh, I forgot PyGame, the player sprite. So there's probably several of them, so we can change them all at once. So our old player sprite list is now the player object has a sprite list built in, and the indexes are still the same as they were. So I'm just going to change the word part and not worry about the indexing. And hopefully that'll catch it. Replace all. Zero occurrences. Oh, whoops, I'm in the wrong file. You do have to make sure you're in the right file with that. So let's try that over here. Control H. Replace player sprite as a variable in camel case with the player object's sprite data. 5 occurrences. So that's a much better sign. Close that. Line 49. What? Name player is not defined. Oh, this one did still need to be a player sprite. Did you notice that error? I remember from a couple hours ago when we started class, they said we're allowed to put line breaks by a comma separated list. So it gave the error message on line 49, but the error, all of that could be one line. So the error was actually way up here. And now it's just a matter of tracking down the errors till we get this to run. Line 57. Player is not defined. It should be. Let me get this old stuff out of the way. There's that. Oh, that comma right there was actually the problem. Let's try that again. So debugging stuff, line 46, still saying player is not defined. Why is player not defined? Looks like it's spelled right there. Oh, there's the problem. The control, the find and replace went too far. Oh, I forgot player bounds. So once again, find and replace player bounds as a variable with player dot bounds. Replace all. And looks like we're really close. Hopefully we can get this running in the next couple seconds. Wait, did I not just replace that? Oh, saving helps. There we go. So The character moves the same, interacts with coins the same. Ooh, with a minute to spare. So does anybody have any questions? I will do that same thing for the coin, and then I will send this out as an example. So I will turn the coin into a game piece object and then send this out for reference. But does the object-oriented stuff make sense there?
Yeah.
That's kind of a important concept in programming. Hopefully that makes sense, because now instead of all that separate data, we just have this one thing. Our player is a single thing that keeps track of all his data, and we're out of time. There's a video with a shorter way to do this on Ivy Learn video lectures. You'll see that. Otherwise, I will see you all on Wednesday unless somebody had any questions. All right, we all have a great week, a great evening. I will see you on Wednesday, and we are going to get into graphic stuff and move on to another game engine where we're not typing and don't have to deal with typos because the computer will do the typing for us. Have a good one.